Number 14, and this is polar complex. And the question is convert 2 minus 2i, we're taping, to polar. Okay, so 2 minus 2i. There's about 19 different ways to do this. Some of them are very quick, depending on how well you know the unit circle. You know your unit circle, this goes like that. You don't, then you don't. I always like to draw it. Here is my x-axis, here is my y-axis. So this says go 2 units along the x-axis and then 2 units down along the y-axis. You got a couple choices here. What kind of triangle is this?
45, 45, 90.
45, 45, 90, isosceles, the legs are equal.
Which means that your radius is going to be 4.
Oh, not quite.
4 root 2.
2 root 2.
2 root 2.
I was...
Your radius will be 2 root 2, either because you remember that it's a pattern of side, side, side root 2, x, x root 2, or because you do the Pythagorean theorem and you get the square root of 8, which simplifies to 2 root 2. And so you would rewrite this as 2 square root of 2 cis. My favorite way to write that angle would be 7 pi over 4. What are some other possibilities for writing an angle? 315. Negative 45 would also be possible.
But I don't get how the cosine and sine are supposed to be root 2 over 2, right?
Yeah, this is a little bit of a tricky one for that one. That method that you were doing so well with yesterday, this becomes problematic here. What would you factor out of this to leave root 2 over 2? And you would factor out, you could rewrite this, let me see if I can do this right on the first try. If I take out the 2 square root of 2, the way we talked about yesterday was you factor the length of the radius out, and what you're left with tells you the cosine and the sine of the angle remaining. So if you can look at this and see that you would factor out 2 root 2 to be left with root 2 over 2 in both cases, that would be some pretty impressive mental math. But if I were to distribute this, I would get square root of 2 times square root of 2 would be 2, times 2 would be 4, divided by 2 would be 2. I'd be thrilled if you did this one in your head like that. That would be amazing. Kathleen.
So, just so that I can, get this down and such. So basically you take the hypotenuse and then you divide, well, that's 2 root 2 there. So then you...
Yeah, I'm saying the magnitude and the...
You take the hypotenuse and then you divide out a common number to get the cosine and sine, and then from the cosine and sine you find the angle.
That's one way to do it. That's one way to do it. That's a good strategy. But some of these might be recognizable by faster ways. In this case, you could find the hypotenuse, which is the same as the radius in this case, factor it out of the terms, and then what's left will be the cosine and sine of an angle you should recognize. For this one, though, I wouldn't do it this way. I would draw it and look at the fact that it's an isosceles triangle.
Yeah, it's just that sometimes when there's, a number in front of a radical, it's let's say the number 4.
Well, hold on. Let me do one of those next. Any more questions on number 14?
But I'm just saying that it's hard for me to recognize what to simplify it to, or what it divides out to, or anything like that.
Okay, I'll give one big hint on this. Okay, I'll give one big hint on this. First off, let me give you a big hint on this one. If the components are the same, these are the legs of the triangle. If you have the same A and the same B, what angle should you be thinking of? 45. You're going to have a 45-degree reference angle if these two numbers are the same. You might not know what quadrant it is right away until you look at which one's positive and which one's negative, but this is going to be some sort of 45-degree angle. Does that make sense?
Yeah.
Okay. Here's your other hint.
Can we do 26?
Yes. Is 26 was that one you were supposed to know?
No, it's I minus I. I mean 1 minus I.
Okay, let me do that after this in a second. I'll do that after this one. Here's your hint. If I'm going to ask you to do this without a calculator, then they've all got to fall into some pattern. And that pattern is the length of the radius has to be multiplied by one of three things. Either plus or minus root 3 over root 3. Let me write this bigger. Plus or minus root 3 over 2 plus or minus 1/2 I plus or minus 1/2 plus or minus root 3 over 2I.
Multiplication.
This is just, give me one sec before I answer that. Plus or minus root 2 over 2 plus or minus root 2 over 2I. If I'm giving you something without a calculator, this is what you and I talked about this morning that seemed to help. If I give you a question I expect you to convert without a calculator, somewhere the rectangular form has to be able to be made to look like one of these three things. And this one is just a case of being the same A and B component. Because it has to be the cosine and the sine of the same angle. And if I'm making you do it without a calculator, it has to be a multiple of 30, 45, or 60. Does that make sense? Only
that wasn't.
Pardon? And there were some that weren't. That's when you pull out the calculator. So, Kath, for a slightly easier example, and Parker, this is one I wanted to get to you as well. If I give you to convert, let me pull one out of the book. 18. Number 18 was -2 plus 2I root 3. That's what it's kind of meant to be, but I want to show this kind of quick trick again from yesterday. You see a square root of 3 in the second spot. So which one of these three possibilities does it most resemble?
60 degree.
That one.
Yeah, this one in the middle. And if we're talking about a cosine of 1/2 and a sine of root 3 over 2,
30 degree.
Divided by 2?
60.
now this is 60. Cosine is 1/2 and the sine is root 3 over 2 when it's 60.
Okay, yeah.
So we're looking at a 60-degree reference angle. What quadrant is this in if it starts negative and then goes positive? Alba says quadrant 2. Does everyone agree with that?
Yeah.
Quadrant 2. A 60-degree reference angle in quadrant 2 means, means a 120-degree standard angle. So I'm looking at 120 degrees. Now what's my R? My R, my length of my radius, is what I would have to factor out of this to make it look like this one.
2?
4, because I've got to get 2 times what equals 1/2. If I pulled a 2 out, I'd be left with 1 plus root 3. I want it to be 1/2. So I have to pull out a 4, and that would leave me with -1/2 plus root 3 over 2I.
Oh, wait. Can't you just divide it by 2 to get the 1 over 2 and then the root 3 over 2?
Nope, I have to pull a 4 out.
You divide 2 by 2 is 1.
Yeah, if I divide this by 2, I only get 1. Now, we're not actually dividing. I know division and factoring are very similar, but we're actually factoring. So this is 4 cis 120. How easy is this way of looking at it? Depends. How well do you know your unit circle, and how quick are you at factoring out numbers with fractions being left? Too quick. If you are, this is going to be the way to go. And it'll be a problem on the ones like we just saw with the 2 and the 2. But that's where you have to think, okay, they're the same number. So I'm looking at a 45-degree situation. Now I'm going to do 26. May I erase this?
Yeah.
Anyone have 18?
No.